Hello Oracle Database Geeks, this is Justin, and in this Oracle Database video YouTube tutorial I am going to show you how to create an ASM instance. Now, what is an ASM instance? Well, ASM stands for Automatic Storage Management, ASM, and it was first introduced in Oracle Database Software version 10G. And what it is it's Oracle's own version of an LVM, a Logical Volume Manager. Now, what is a logical volume manager? Well, let's take operating systems as examples. Microsoft Windows operating system has a feature called dynamic disks, and with dynamic disks, what you can do is you basically put all these disks together, and you can just select storage. You don't care where it comes from. So you just want to partition like a D drive or an E drive or whatever. You just select it, and it'll put it out there for you. It also lets you stripe data across disks, which is for performance, and it manages. It's a software layer. An LVM is a software layer that manages your disk, okay, and your access to disk, and your performance of disks, and so on and so forth. Now, in the Unix world, Unix proprietary world, AIX, which is IBM's version of the Unix operating system, has had an LVM integrated into the operating system by default for many years, since probably the early versions of 4, I believe. And it's called LVM, just Logical Volume Manager, LVM. And that Logical Volume Manager, like many Logical Volume Managers, allows you to what they call concatenate disks, where you can take multiple hard disks, as seen from the OS. You can put them all in this big pool. So if you have 3 separate disks that are 3 gig each, you can put them into a pool to make one big 9 gig pool. And then you can then every time you need space for a file system or whatever, all you would say is, I want 2 gig, or I want 1 gig, or I want 200 meg, or whatever. And you as the user, or the admin, or DBA, or whatever, you don't care where that space is coming from or how it's allocated at a disk geometry level. You just want that space somehow, and the LVM allows you to do that. Okay, Solaris, prior to version 10 of the Solaris operating system, Sun OS, it did not have an LVM integrated that came with it. It used a product called Disk Suite. From Solaris version 10 and above, it uses Disk Suite, comes integrated. It comes in with the Solaris already installed, I should say, with the Solaris operating system. HPUX, which is another proprietary Unix version from Hewlett-Packard, uses a third-party software product known as Veritas File System, VXFS. It uses Veritas, which comes installed by default with HPUX. You could also buy Veritas File System from the Semantics Corporation, software corporation, for Solaris. It was popular with Solaris prior to version 10 for a very long time. You could also, I've also seen it run on AIX in the field, which I don't understand why you would do that, except for keeping things consistent across platforms, because AIX has a very good logical volume manager integrated into it. So, but it is supported in AIX. Linux distributions, mainly the enterprise supported versions for businesses, Red Hat and SUSE, have an LVM called Linux LVM that comes installed and configured, ready to go on Linux operating systems. Okay, so Linux even has an LVM now. So LVM is definitely the new way to manage, and on a PC-based architecture, it also eliminates the 4 partition limit, primary partition limit on disks. It doesn't eliminate it per se, but what it does is it makes you unaware of it. Okay, what do you care? So you can create as many file systems and logical volumes or partitions as you want within one primary partition, because LVM is basically managing all of that. Okay, so there are a lot of advantages to LVM. But getting back to Oracle, okay, has its own LVM now called the ASM. And basically what this will allow you to do is there's an instance called an ASM instance, which runs on the same server, the same operating system as your database instance that it manages. And basically you create what's called disk groups. Okay, and it does the same concept as an operating system LVM. Okay, group of disks that we discussed earlier, and it doesn't matter, okay, where the disk comes from. You're telling ASM, look, these group of disks I want you to use for the database which you are managing. And ASM says, okay. And every time you create a table space or whatever, you're just saying create table space, 10 meg, and you don't have to worry about where on the file system these disks are, or what disks you want to use, or what partitions you want to use. You're just taking it from a disk group name, and ASM will just worry about balancing that disk out and whatnot. There's also performance benefits to ASM. ASM will allow you to spread the disk load out. You can mirror your data files. You can do a lot of cool things with ASM. Now, this isn't per Oracle Corporation. This is just Justin's observation. I noticed in a lot of Oracle, I read a lot of Oracle publications, and I noticed that in a lot of Oracle publications, technical docs that I read on a daily basis, that they're really, even on different topics where they refer to disk storage, I noticed that Oracle is pushing a lot of users, a lot of customers in the field today to ASM. Okay, now, and especially in a rack environment, okay, real application cluster environment, okay, the high availability cluster solution for Oracle. They're really pushing it as well. Okay, I'm not saying that's wrong or right. It's just an observation. I'm just making a statement. It's not an opinion of any sort. Now, what are the other options to store storage to store your data files, which is basically your data or your control files and your online redo log files and whatnot? Well, you can have what's called you can put them on a regular cooked file system. We call them a cooked file system as files. And that's what a majority of my videos do, and that's what a majority of customers do. That's when you have actual files in a directory structure, that whether it's NTFS on Windows or JFS2 on AIX, or Unix or Unix file system UFS, or ZFS on Solaris, or whatever, or Veritas on HP, or whatever your file system is, ext3, ext4 on Linux, whatever your file system is, it'll allow you to just CD through directories, dir or ls, and you can actually see the files that make up the database. And it's easier to manage, I've learned. A lot of people like that. Okay. The other option you have is you can create them on what's called raw logical volumes or raw disks, and basically with no file system on them, no file system on top, cooked file system on top of them. Okay, and that's a little more difficult, not difficult per se, in skill-wise, but that's more, to understand it. It's just, there's no Oracle file systems on this server, so from a Unix perspective, so that means there's no Oracle database. Well, no, it doesn't mean that. It just means that the storage you can't see. Okay, so those are the other two options as opposed to ASM. But the first thing we need to do is, and what this video focuses on, is we need to create an ASM instance before we can manage our database data. So let's look at the Oracle database our regular Oracle database that we have running on this Windows server. We set our Oracle SID to the name of it, which is finance. We ensure we're set properly. Okay. And we connect by SQL Plus to it. We ensure we're connected with the sysdba user, and we do a select name from $sign database to ensure we're connected to the finance database. Now, as I'm sure you know, Oracle databases are made up of table spaces to manage your data. Okay? And some are required table spaces, which you'll find in any Oracle database, i.e. system and sysaux, and some are application specific and optional table spaces, app and app02, for instance. Okay, and some have certain functions within Oracle database, such as temp and undo. Now, if we do a select name from $sign database, this is basically what we call, from $sign data file. This is basically what we call the physical schema of our database. This is the structure, and it's in the cooked file system is where our database, how our database is made up here. And we see the data files, DBF files, database files, the physical files, if you will, which make up our table spaces shown up here. And we do select name from $sign control file. We will see the physical files, if you will, which make up our control files. And if you do a select member, from $sign log file, we will see the physical files, if you will, which are our online redo log files of our database. Okay? And from an operating system perspective, if we cd to /database or data finance, okay, which is a path in our NTFS file system, which means that it is a cooked file system, on this Windows server. So we cd to c:/database/oradata/finance, and we do a dir. We will see all the data DBFs, control files, and redo logs, which make up our Oracle database. Now, the first thing we need to do is we need to create an ASM instance. So what we need to do is we need to move to our Oracle home directory, which in this server is c:/oracle app product 1110 db_1. And the Oracle home is the location where our Oracle database software is installed. In this case, it's c:/oracle/app/product/11.1.0/db_1. Okay, and what we need to, and this is where all the config, and there is a subdirectory under Oracle home known as database on Windows. On Unix, it's DBS. And if we look in this directory, these are all the files, these are all the configuration files for the instances we have running on this server. First thing we need to do is we need to create a config file for our ASM instance, a parameter file, just like the same steps we would have to do to create a normal database instance. Okay, and first thing we need to do is we need to set our Oracle SID to the name of our ASM instance. All ASM instances must be called the following: set Oracle SID plus ASM. Okay, so set Oracle_SID equals plus ASM. So Oracle instances must be set to plus ASM instances. And we ensure we're set properly, which we are. Now, we create a file called init, short for initialization, the name of the instance, plus capital ASM.ora, short for Oracle. Okay? So far, no deviation from our normal. Now, you will notice that in a regular database instance, okay, there is only one parameter, and if you refer back to my How to Create an Oracle Database video, you'll see this. You'll note that there's only one parameter that's needed in the P file for a regular database instance, and that parameter is db_name. Similar to an ASM instance, there's only one parameter needed, but it's not that, it's this. Instance_type equals ASM. Okay, that's really the only parameter needed, okay, to start an ASM instance, and it's instance_type and equals value ASM. The other possible value is the default value, which is implicitly set, RDBMS, and that just means it's a database instance, which obviously it always is for the most part, okay? But with the introduction of ASM since 10G, okay, there's now a need for another type of instance, ASM. Okay, so we have our instance type set, and we take a look at the contents of our init asm.order file. There it is, instance_type equals ASM. Now what we need to do is we also need to create a service for ASM, just like we would with any other Oracle database instance that we're creating. And this service thing is a Windows thing. And we do that aura dim -new -sid space the name of the instance plus ASM. And this will automatically start the service as well when it's done creating it. Okay, service started successfully. Alright, now what we have to do is I'm going to show you a typically in an ASM environment, especially in Unix and Linux, in the Linux world, ASM uses raw logical volumes for its storage. So basically what you would do is you would tell ASM use these raw logical volumes, okay, and just store the data. There's no file systems on there, I don't care. A raw logical volume in the Unix and Linux world are logical volumes that don't have file systems on top of them, okay? There's always a logical volume of some sort under a file system when it comes to, which is a partition basically, okay, which is virtualization of a disk. You're taking a disk and chopping it up into smaller virtual disks, so to speak. Okay, so there's always some kind of logical volume under a file system, but basically in ASM you're saying, here are the disks, i.e. the partitions to use, okay, for this database storage, okay? Now in a Windows environment, there's a cool little tool called ASM tool, which allows you to create files, okay, which we're going to trick ASM of thinking that they're raw logical volumes. Okay? And so we're going to create a directory called MK. So we're providing a storage space for ASM to use. That's what we're doing here. We're creating a directory called ASM disks. We ensure that our new directory is empty, which it should be. And we issue the following commands. ASM tool create C:/ASM disks 1 ASM (300). So we're going to create 300 meg files, which is going to give us about a gig of space. Okay, which would be about 900 meg. And while this is a lot, it's a lot of space, so it's going to take a few seconds. So I'll pause the video while this runs. Okay, that disk is created, and if, I'm sure you guys, since people who watch these videos are smart people, I'm sure you realize that I made an error here, and I put it in the root of C as opposed to the directory that I created for it. Oops. I also named it wrong, so I've got to make a few changes here. ASM disks 1.dsm to C:/ASM disks. Be careful. ASM disk 1.asm. Oops. Okay. dir C:/ASM disks. There's a 300 meg disk. Now we'll create another one called ASM disk 2 and make sure it's in the ASM disks directory we created. And I'll let that 300 meg. So we have one 300 meg file created in ASM disks. ASM disk 1.asm, pre-formatted disk file, I should say. And now we launched another ASM tool command to create the next one. Now, typically you won't be doing this step. What you'll be doing is you'll be calling the Unix SA, which is me, I'm a Unix SA by trade, and a Linux SA, and you would say to us, we're putting up an Oracle database, this database needs 200 gig of space, we're projecting. And we'll say, okay, fine. And we'll create, maybe we'll create 450 gig partitions, and we'll say, here are the name of the 450 gig partitions. And they're given file permissions, by the way, Unix file permissions, for the Oracle owner that owns the ASM instance. Okay, it's a little different in Windows than it is in Unix or Linux. Okay, and then the Oracle, and then I'll say they're called /dev/Aura ASM1, Aura ASM2, 3, and 4, and then the DBA will say, okay, thank you, and they'll tell ASM to use those logical volumes. That's basically how that works. Okay, so while I was jabbing away there, the second disk is completed. File, I should say. dir, there it is, 300 meg each. Now we're going to go ahead and create our third one. Okay, and everything else is good. We just change this to 3, and we let the third file creation do its thing. And while this runs, I'm going to pause the video. Okay, so if we look at our ASM disks directory, we will see that we have 3 files, all making up about 900 meg. See it right here. Okay, ASM disk 1, ASM disk 2, and ASM disk 3. Now what we need to do is we need to add, well, we could have done this before, but it doesn't matter, 2 parameters to our plus ASM Aura file. Okay, we already have the instance type parameter. We need to add ASM underscore disk string equals C:/ASM disks asterisk. And we need to add underscore ASM underscore allow underscore only underscore raw underscore disks equals false. Okay, and let's take a look at this. Okay, at these two. The first one, ASM underscore disk string. ASM underscore disk string basically says to ASM when it starts, ASM instance, it says use the files which are in this directory, okay, to store the databases that you manage to store the storage in. So it's basically telling it, and basically in a Unix SA world, after I create your partitions, you would just put the name of those partitions in. Or you could just type in this, dev Aura ASM asterisk. And as long as the Oracle user, the ASM user, instance user has access to these logical partitions, okay, they will be able to, you're just saying anything that it starts with that name, use. That's what the wildcard is, use as storage for the Oracle databases you'll be managing, okay? And this is an undocumented parameter which should only be used under the guidance of Oracle support. Justin on YouTube, am not Oracle support. So it's not worth much to say, well, Justin said that, and that it doesn't matter, okay? Only Oracle support can tell you to do this. But basically, if you're playing in a lab, no big deal. But basically, it's a undocumented procedure because it has an underscore in front of it. All undocumented procedures have an underscore. And ASM underscore allow underscore only underscore raw underscore disks, we can surmise that by the existence of this parameter, that by default, the ASM only uses raw logical volumes for its storage. Okay, we're basically overriding that default behavior of ASM, and we're saying use files that we pre-formatted files that we created here. So we're tricking ASM. Okay, we're fooling it to say, I know you usually only use raw logical volumes, but I would like you to use files that I pre-formatted as the disk storage because I don't want to use raw logical volumes for whatever reason. Okay, so I don't recommend ever using undocumented procedures in a production environment anyway. But this particular undocumented procedure, okay, is only relevant to what we're doing here since we have files. Okay, so we have an instance service created, we have our storage created, we have our proper parameter set, we have our Oracle SID set, which we'll verify now. So let's go ahead and let's start our instance. And we do that as if it's any other Oracle instance. Log in with SQL Plus and type in startup. And it says ASM instance started instead of Oracle instance started like it usually does. And you notice you have an ASM cache, which you don't have in regular RDBMS instances. And you get a message or 15110 no disk groups mounted. Okay?